automatically and connect the document by recursively fetching links, giving a set of start pages, mostly used by the search engine to download all the pages and create an index to perform the fast search.
Okay, so the end goal of this crawler is to get the content and build the index, right, to support the search. Or is that end goal, or you want me to build a general system that can support different goals?
The one is used by the search engine, not just download the content and store it. And it can also, one is used by search engine most time, and it also can used by validate the web page link is valid, or also can check if the content is saved by multiple places.
Oh, okay, cool. So you mean like we need a support search or like do some analysis, right? So
yes.
Yeah, okay.
The system can help to cool. Use this test case. Yeah.
So I assume that is the functional requirement. Is there any other functional requirement that I should be aware of?
That's it.
Okay. And then for non-functional requirement, I assume we need to build the highly available, reliable system. But I have a question about the latency. Since it looks like we normally run the crawler asynchronously, what's the requirement for latency? Do we need how frequent you want to crawl the websites, and how many websites do you want to search from?
The latency is flexible. It depends on how often the web page content is changed. So it's dynamically designed. And for the size will be the whole world. The 1 trillion or 1 billion.
Okay.
1 billion. Yeah.
Okay. Given that, I think one process is definitely not enough, right, to meet our goal. So I think I will just give you a workable solution, and then later we can discuss how can we make it more scalable. For example, we can calculate how many crawler we need to achieve our goal. Is that okay?
Yes. Okay.
Okay. So to give you a workable solution, we can first break down the system into multiple components. I think first we need a component called URL retriever. Right. Its job is to get all the URL that is supposed to be crawled from, right? And then once we get the URL, we need call it downloader, URL downloader, to download the content from those websites, right? And then after we download that, we got the HTML format. We need a component, call it probably content parser, and to basically get all the link from the original page, and then this parser gets the links and then put it back to give it to the retriever, so that we can recursively crawl all the websites, right? And then we probably need something like indexer, or this is like the secondary requirement. We can just use the indexer here to show how we build a general system that's to support different scenarios. Okay, so this is the main components. Then let me show you how these components work with each other. So the whole flow start with the URL retriever. The retriever will get the URLs, and it normally start with C URLs. The C URL we can get the CIL from the Alexa. For example, we can get the top 100 popular websites, and then we can start crawling from those websites, and then get all the links. Hopefully get all the links from those 100 websites. This is one technique to build the CURLs. Once we get the URLs, we give it to the retriever. Retriever get the URLs, and maybe we can have a cache here for the retriever, so that we don't we can avoid the duplicate URLs, right? And then once retriever get a URL, it pull it into the a message queue to give to allow the downloader to get those URLs. So like and then the downloader can get those URLs and start downloading from the website. And the downloader should be since we are just putting the URL in the queue, the downloader should talk to the DNS server to get those IP address, right? So to know where to download those things. And then in the middle, we can put some cache here, because we can access the same domain multiple times, then we can save those information like IP address in the cache, so it can be more efficient here. Okay, this is downloader. Once we download the content, we put the we again can pull it into the message queue again to give the put the content in the queue, in the message queue, and so the content parser can get those raw content from the message queue and start parsing the content, the website. And then after it pass the content, it can save those content into a database. And here, since we are downloading, passing the content from the world, and we can use distributed file system to save those relatively low content. And then we can put it here. It should be a file system. And then the indexer or other analyzer, for example, can start reading the content from the file system and then do its job, right? So it's like, this is how we save the content in the DB. And then after, meanwhile, the content parser will retrieve the URLs from each web page and then pull it back to the URL DB. Now this DB is not only for CURL, it can be like in general for URL storage. Okay. And then the retriever can get those URL from the storage and put it back to the message queue. So yeah, so this is the whole flow, and we can. Is that sounds okay to you?
Yes, that's great.
Okay. So this is the workable solution. I'm not sure if you have any questions or if you think that anything we can improve. If not, I can like have some idea to improve this whole system.
Yeah.
Before that, yeah, I want to ask if you have any questions.
So far so good. So
Okay.
you go ahead.
Cool.
Yeah.
Okay, cool. So there might be some problem for this system. First, like we want to control the speed we crawl each website, right? Because if we crawl each website too frequently, the website may block our request, right? So we want our system to be polite. So in order to do that, we have some we can create some scheduler in some components, like in retriever. We can get some scheduler, and for downloader, we can also create some scheduler. The scheduler's job is to to decide how frequent we should download from each website, and in order to come up with the schedule, we probably need something a different component. I call it a recurrent job. Yeah. Its job is to go to each website to download the metadata of each website, and then those metadata usually contains the rules that a crawler should behave, and then the recurrent job should get the URLs and try to access those URLs to download the metadata and then save those metadata back to the URL storage. The storage will also contain some metadata. Okay. This is like one thing we can improve here. So for this DB, we might need since this is we will store metadata. It will be the structured data, and we probably need a SQL DB here. This is file system, and for this message queue to avoid the message, the URL loose, we can use Kafka here. So it will handle the data persistency to avoid data loss. Those are a few points that I can think of to improve. Yeah, so, and also like for here, the downloader will query the metadata DB to get the metadata, and then you will know how frequently you should query those websites. So far, this is my design.
So you made
questions or concerns?
Yeah, about that the metadata. What's the metadata for? Is
the metadata will contain. It will download the metadata from the website. The website will it will show like how frequent you should access, your crawler should access website, for example, and like what's the client name you should use, so that the website will know, okay, this is the web client, and it's a legitimate crawler that we should allow access, right? So it contains something like that. Does that make sense?
Okay, I know there is a robot.
Yes. Basically, it will follow the Logbook protocol to download those metadata from the website.
Yeah. Okay. How will you if you know some URLs may be duplicated? How you think about it? Handle those duplicate URL.
And since we always save the URL information here, so for each column we might have the URL ID, we have the link, the actual link, and also the status. The status meaning also the update time, right? So
Okay.
the queue, it will check the status. If the URL is being processed or the last time it was processed is within a short period of time, then it will avoid like dumping those URL to the queue. So we can avoid accessing duplicate URL in a short time. Does that make sense?
I mean, some content, they maybe you have lots of content. When you parse the content, you retrieve the URL, right?
Mm-hmm.
Then those content may have same URLs.
Yes, we can use like key value store to save those URL that about that we are going to crawl, right? And when we pull it into the DB or cache, we will check the status, right? If for the same URL, we can read it from the DB to check whether this same URL has been processed before. If it's been processed or it has been processed before, then we can avoid using it. Does that make sense? Because the content parser, we can add a job, we can add component here to, for example, like this, we call it deduplicate, right? So we can add a service here. So when we pass all the URL from the parser, they put it into the deduplicate service. To this service is to query to see whether each URL has been processed or not. If it has been processed, then we don't update the URL DB, and then to avoid that the retriever get it again. Does that make sense?
Maybe you can think about the hash. You maybe think about some hash value to check, to check if the link is same link or not. But because we are recursively parse, right? Some URL we do now retrieve multiple times. Okay.
Cool. Okay.
Because the content is updated, we also want to serve updated data.
Oh, okay. I see. So your point is not the same URL. Your point is whether the content has changed or not, right? Okay.
There's two.
Mm-hmm. Okay, got it. Okay, sorry. Yeah, I didn't fully understand the question. But to avoid the duplicate content, yes, I think your point is valid. We can hash the whole content to see if it has changed or not. And then when we download this the content from the same website, we have the content parser here to hash the whole website, the content, and then if it has not changed, the content has not changed, we can change our scheduler to so that my point is that we can adjust the scheduler accordingly. If the content doesn't change frequently, we can crawl the website less often, right? So if if we have the duplicator or the analyzer, content analyzer here, we know that a website is changing frequently, then we can let the scheduler or the downloader work more frequently to download the same website more frequently. That's my point. Does that make sense?
So, when you talk about your storage, to analyze some storage,
yeah, the DFS.
Like the URL.
Okay, here.
Yeah. Yes.
Okay, what's your question, concern?
So what data you store in that
okay, what's the schema, you mean?
Yeah, schema and
cool. Like I have the metadata here. This is the URL metadata. So the metadata will show include the ID, the actual link, the status, like whether the website this website has been processed or not, the update time. The last time we query this this website, this is one thing. We can also have basically that's about it. Yeah, you store all the URLs, including the status that we care about, some attribute we care about, like for the schedulers, and yes.
Because it's worldwide worldwide, and so do you think you will like a domain name and have two layers? One is for domain layer.
Okay.
Then the domain layer, then they start to have the URL.
Yeah, that makes sense. Yeah, we should have a domain because the domain will help us improve our efficiency. For example, for the downloader, right? We only need to get the IP from the domain name, not the whole URL, right? So if we can save the domain name here, the downloader will be more efficient. Yeah, that's a valid point.
Okay, then if you think about it, how you sharding?
Sharding. Okay, so we can talk about how we make this system more scalable. We can create multiple retriever downloader here. The process, like we can briefly calculate how many process we need, right? You mentioned that 1 trillion URL.
The website.
Yeah. Okay, 1 trillion website. Okay. I'm trying to calculate. Like, do you know how many? Like, how many website we need to query per second? Like, because do you have this number?
No.
Okay, then we can calculate it. 1 trillion. it's around 11K, 12K. Not sure if I got it correctly, but it's a 12K per second that we need to, like how long you want, how frequent you mentioned that this is the flexible, right? Like assuming like we want to access those websites in a week to analyze all the websites. Is that a reasonable estimate?
Yes, and you can say you have the scope like the most frequently maybe is 5 minutes, and the least frequently is 1 month.
Okay.
Then other will based on how frequently the content is updating. You can adjust it. Yeah.
So I assume like when you say that there are different frequency, I mean the same I mentioned. You mean the same I mentioned that the downloader will change the schedule accordingly, right? According to how often the website is changed. Is that okay?
Yes, right. I think it's okay because your downloader is based on the message queue, right? Okay. If I understand it, so it's based on the retriever to decide it. Which URLs to put in the message queue.
Cool. Yeah. Okay. Then we can just assume like every second we need to process 1K, for example, website. Is that a reasonable estimate? 1 second 1K. Then we can estimate for each process. I assume that each process can process one page in 1 second, right? Then we need 1K. We need 1K process to work at the same time. So your question is how we split those requests to 1K process, right? We probably need for each machine we can create 100. Let's estimate 100 process. Then we need at least 10 machines to handle the whole system, right? 10 machine. Okay. And then we can shard those URL based on the URL ID here. This is the one solution. Maybe this is the workable solution. What do you think? Do you think does that sound reasonable? We can shard it by ID and split those URLs into 10 machines. So this is one solution. Another solution, we can shard it by the location. So imagine we need to crawl the website from around the world, right? So we can deploy those crawler in the machine in different region, so it can be faster. So yeah, so the strategy will be two mechanisms. One is to shard it by the location. Another one in the same location we can shard it by the URL ID. Does that make sense?
Yeah.
I think this machine, the estimate might be smaller than the real situation. We might need more than that. But yeah, but do you have any other question or concern?
So you mean, how many machines for the retriever?
Based on our estimate, like 1K website per second, a process can process maybe one second is a little bit too ideal, maybe. And then we need to have 2K process, right? 2K scheduler and downloader. And for each machine, we can have 100 process, or maybe like 10 process. So we need 200 machines here. We need 200 machines here. Each machine has 10 process. Okay, this is my estimate and solution. 200 machine, and then each machine has 10 process.
For retriever.
Yeah, for either retriever and downloader, because they work parallelly. So we need to have 2,000 each.
How about the data partitioning? The URL, the database.
Right, the database. Okay, here we will have one more attribute called location, for example, and we can split or do the data migration based on the location, right? And then for the URLs that is in the website that's in China, we can, for example, we can save those URL in this database, and then we can then partition those database based on the ID, and then split the URLs to the crawlers. Does that make sense? So like two things. One is to split the data by location. Different data center or different region will have the different URLs, and then if it's in the same region, we partition the URLs based on the ID, so that we can get those URL to the right scheduler or to the downloader, so it can be more efficient to download those URLs. Any more questions?
Okay. So, how you handle the failures? Like,
Okay. For failure, they are like what I can think of one failure is that when the website is down, right, we may fail to download the content. So for here, we will have a retry logic here. If we fail to download the content, we will retry later. The downloader will put the task back to the queue, so you can do it later. This is one failure. Another failure might be the message queue might be down, right? Then we can use some write ahead log here to make sure we don't lose any data, any URLs. Like, can you what else? What failure are you thinking? So we can discuss.
Like the retriever or scheduler.
You mean?
Is there any?
Go ahead.
Is there stateless or
you mean they are stateless or not? Your question is?
Yeah.
We can decide it to be stateless. We can design it to be stateless, so that when one process is done, we can create a new process, right? So to make it stateless, we have to. So imagine that when the downloader is downloading this URL, we will write a log before we actually download this thing and mark it as done, right? If the scheduler is done, we will read those write ahead log, and then create a new process and put those and then know what task is left based on those logs. So then we don't so we don't miss any URLs. Does that make sense?
Yeah. So how you detect the scheduler or retriever is done?
So we can have a master worker to receive the heartbeat from those scheduler and downloader, retriever and downloader, right? So if the master service hasn't received the heartbeat from those component for a specific time, the master will mark it as done and then create a new process and let the new process pick up whatever job is left from those process. Or we can use something Zookeeper to something like that to make sure the scheduler, there are always some scheduler, retriever and downloader are running. Does that make sense?
Yeah.
Okay. You have any more questions or concerns?
Could you talk about a little bit how you avoid the coroner traps like an infinite loop?
Or you mean, what do you mean by infinite loop? When will that happen?
Some web can unconditionally or inconditionally have a same like a circle URLs. So when you correct, you will go in the circle.
Okay. So I think it's the same thing as we discussed to avoid the duplicate URL. Okay, this is for. I think we can. In this case, we should use. We haven't mentioned that we should use the BFS to pass those URLs, right? And then for the top level website, if we have processed, we will mark it as done, so we can avoid process the same URL. We use BFS to do the code. Does that make sense? And then we can use this service to avoid process duplicate domain in the website. I think it should be website. Since like I mentioned, the key is the URL in this cache or this store. We save it. We save the URL as the key, so we can easily check whether the same URL has been processed or not.
I think it's already 45 minutes.
Yeah. So.
Then our last question is how, but okay, then we're done. I think how you extend this system. Like I saw there's say it's to customize, not a generic. How you extend this system?
Extend it here for, like I said, we save those things in the DFS, right? We save it as a log content. So according to different scenario, we can read the content differently. Like for indexer, we can read something that the indexer is interesting. For analyzer, you can read the content differently. This is we put everything in the DFS, so it can support all the scenarios. This is we save it as HTML format. So we got everything here. We got all the information. Cool. Yeah, we are done. 林老师，我们完了。